What if I told you that right now, at this very moment, your death already exists? Not metaphorically, not philosophically, but actually, physically exists in the same way that your breakfast this morning exists. What if everything you think you know about time past, present, future is completely, fundamentally wrong? Here's the thing that's going to break your brain in the next 3.5 hours. According to our best understanding of physics, validated by over a century of experiments, the future isn't something that's going to happen. It's already there. It exists right now. And the flow of time, that sensation you have of moving from past through present into future, that's an illusion. It doesn't exist in the physical universe at all. I know what you're thinking. This sounds insane. But stay with me, because by the end of this video, I'm going to show you the experimental evidence, the mathematical proofs, and the scientific consensus that supports this reality-shattering idea. And more importantly, I'm going to show you what this means for your life, your choices, and your understanding of existence itself. Before we go any further, smash that like button if you're ready to have your mind completely reconstructed. Subscribe and hit the notification bell, because this channel is dedicated to ideas that change how you see reality. And drop a comment right now telling me what country you're watching from and what time it is where you are, because as you're about to discover, that simple piece of information is way more complicated than you think. Let me start with something that happened in 1905 that changed everything we thought we knew about time. Albert Einstein, yes, that Einstein published his special theory of relativity. Now, you've probably heard of relativity before, but what you probably don't know is what it actually means for the nature of time. And trust me, what it means is absolutely wild. Einstein discovered something that seems impossible. Time passes at different rates depending on how fast you're moving. This isn't theory anymore. We've tested this with atomic clocks on airplanes. We've measured it with GPS satellites. We've confirmed it thousands of times. When you move faster, time literally slows down for you compared to someone who's standing still. But here's where it gets interesting. If time can pass at different rates for different observers, then there's no universal. Now, think about what that means. Right now, you think there's this moment called the present that's happening everywhere in the universe simultaneously. But according to relativity, that's wrong. There is no universal present moment. What's now for you might be tomorrow for someone moving relative to you in a certain way. What's now for them might be yesterday for you. The physicist Brian Greene puts it this way. Imagine two aliens on a planet 10 billion light years away. They're sitting on a bench, and one is biking toward Earth, while the other is biking away from Earth. Because of relativity, what counts as now for the alien biking toward Earth could include events on Earth 200 years in our past. What counts as now for the alien biking away could include events 200 years in our future. Just by pedaling a bike in different directions, they're slicing through different moments of Earth's history, all of which exist equally. This is where your brain should start hurting, because we're arriving at our first major revelation. If there's no universal now, if different observers experience different events as happening now, then all moments must exist simultaneously. The past doesn't disappear. The future isn't waiting to be created. They're all just there, different slices of the same thing. Think of it like this. Imagine a DVD of your favorite movie. Every scene exists on that disc simultaneously. The beginning, middle, and end are all physically present on the disc at the same time. When you watch the movie, you experience the scenes in sequence, moving from opening credits to final scene. But your experience of watching it scene by scene doesn't mean the ending isn't already there on the disc. The entire movie exists all at once. You're just moving through it. According to modern physics, the universe is like that DVD. It's called block time, or the block universe. Everything that has ever happened and everything that will ever happen exists in one four-dimensional block. Your birth, your 10th birthday, your first kiss, your last breath, they're all equally real, all existing simultaneously in the block universe. You just perceive yourself as moving through it, moment by moment. The physicist Hermann Weyl said it perfectly in 1949. The objective world simply is. It does not happen. Only to the gaze of my consciousness, crawling along the lifeline of my body, does a section of this world come to life as a fleeting image. Now, I can feel some of you resisting this idea. It feels wrong. You experience time passing. You remember the past, you're living in the present. You're uncertain about the future. How can physicists say time doesn't flow when you so clearly feel it flowing? That's the trillion-dollar question, and we're going to answer it. But first, we need to build your understanding of what physics actually tells us about time. Because the evidence for the block universe isn't just philosophical speculation. It's built on experimental results that have been confirmed again and again and again. Let's go deeper into what Einstein actually discovered, because understanding relativity is crucial to understanding why the future already exists. In 1905, Einstein published a paper titled On the Electrodynamics of Moving Bodies. Doesn't sound very sexy, right? But this paper contained an idea so revolutionary that it literally changed our understanding of space and time forever. Here's what Einstein realized. The speed of light is constant for all observers, no matter how fast they're moving. That sounds simple, but the implications are insane. Imagine you're on a train moving at 60 miles per hour, and you throw a ball forward at 20 miles per hour. To someone standing on the platform, the ball is moving at 80 miles per hour. Your speed plus the ball's speed. That's common sense, right? Addition of velocities. But light doesn't work that way. If you're on a spaceship moving at half the speed of light, and you shine a flashlight forward, the light doesn't move at 1.5 times the speed of light. It moves at exactly the speed of light, the same speed it would move if you were standing still. This fact, this weird, counterintuitive fact, has been confirmed by countless experiments. So how does the universe make this work? How can light always move at the same speed, regardless of the motion of the source? Einstein's answer was shocking. Time and space must be flexible. They have to stretch and compress to keep light speed constant. When you move faster, time literally slows down for you. This is called time dilation, and it's not a small effect at high speeds. If you got on a spaceship and traveled at 99% the speed of light for what seemed like 1 year to you, when you came back to Earth, about 7 years would have passed here. Travel at 99.9% light speed, and 1 year for you becomes 22 years on Earth. We've measured this with real clocks. In 1971, physicists Joseph Haffel and Richard Keating put atomic clocks on commercial airplanes and flew them around the world. When they compared these clocks to identical clocks that stayed on the ground, the flying clocks had ticked fewer times time, had literally passed more slowly for them, by exactly the amount Einstein's equations predicted. But here's where things get really mind-bending. Time dilation doesn't just happen at high speeds. It also happens in gravitational fields. The stronger the gravity, the slower time passes. Right now, time is passing slightly slower for your feet than for your head, because your feet are closer to Earth's center of gravity. The difference is tiny, about 90 billionths of a second over a lifetime, but it's real and measurable. We know this because GPS satellites have to account for it. These satellites orbit about 12,000 miles above Earth, where gravity is weaker, so time passes faster for them than for us on the ground. If we didn't correct for this time dilation, GPS systems would accumulate errors of about 6 miles per day. Your phone's map app works because engineers program it with Einstein's relativity equations. Now here's what will blow your mind. This means different people have different presents and different futures. It's not just that time passes at different rates, it's that simultaneity itself is relative. Let's say you're standing still on Earth, and your friend is flying past you in his spaceship at a significant fraction of light speed. You both check your watches at the moment you pass each other. For you, at that moment, certain events are happening right now. Across the universe, maybe a star is exploding in a distant galaxy. But for your friend in the spaceship, because they're moving at high speed relative to you, their right now is different. Events that are in your future might be in their present. Events in their future might be in your present. The physicist Brian Cox explains it this way. The past, present, and future are not the way the universe is. They're the way we perceive it. What we call now is just a consequence of our particular motion through the universe and our position in a gravitational field. This is called relativity of simultaneity, and it's been proven experimentally countless times. It's not philosophy. It's not interpretation. It's measured, verified physics. So let's follow this logic to its inevitable conclusion. If there's no universal now, if what's now depends on your motion and position, then all moments must exist. They have to. Because what's future for you is present for someone else, and what's present for you is past for another person. The only way this makes sense is if all moments exist simultaneously in a four-dimensional structure. Think of it like this. Imagine you and I are looking at a long road from different angles. From where I'm standing, I can see a car that's around a bend that you can't see yet. From your position, that car is in the future, not visible. From my position, it's in the present, clearly visible. But the car exists regardless of whether you can see it yet. It's not created when you finally walk around the bend. It was there all along. Time is like that. What you call future is just the part of the block universe you haven't experienced yet from your perspective. But it exists now, just like that car around the bend exists even though you can't see it yet. The philosopher Hilary Putnam made this argument in 1967. He said that because of relativity of simultaneity, we're logically forced to accept that the future already exists. It's not a matter of interpretation. It follows directly from special relativity, which is one of the most well-tested theories in all of physics. All right, so we've established that relativity suggests all moments in time exist simultaneously. Now let's explore what physicists mean by the block universe, and why this view of reality is so compelling and so disturbing. The block universe is also called eternalism in philosophy. The idea is simple but profound. The universe is a four-dimensional block of space-time where the past, present, and future all coexist. Nothing comes into being or passes away. Everything that ever happens just is. Picture a flipbook animation. Each page is a slightly different image, and when you flip through the pages quickly, you see motion, a stick figure walking, a ball bouncing, whatever. Each individual page exists simultaneously in the book. The motion and the story only emerge when you flip through the pages in sequence. The block universe is similar. Your entire life from birth to death exists as a four-dimensional worm snaking through space-time. At one end is your birth, at the other is your death, and every moment of your life exists as a cross-section through this four-dimensional worm. You right now are just one slice of your complete space-time self. Your past self 5 minutes ago still exists at an earlier point along your world line. Your future self 5 minutes from now already exists at a later point. The physicist Carlo Rovelli, one of the leading researchers on quantum gravity, describes it this way. We are not in time, we are time. We are the process, we are the happening. But in the block universe picture, even that process is static. It's a pattern frozen in four-dimensional space-time. Now, why do physicists take this idea seriously? Because it's not just a consequence of relativity. It's also the most natural interpretation of general relativity, Einstein's theory of gravity. General relativity describes gravity not as a force, but as the curvature of space-time. Massive objects like planets and stars bend space-time around them, and other objects follow the curves. This theory is spectacularly successful. It predicts the orbit of Mercury, the bending of light around massive objects, the the existence of black holes, gravitational waves, all confirmed by observation. But here's the thing. General relativity describes the entire universe as a four-dimensional geometry. It treats space and time as a unified entity called spacetime. And in this mathematical description, time is just another dimension, like the 3 dimensions of space. The equations don't distinguish between past and future in any fundamental way. Time doesn't flow in these equations, it just is. When we solve Einstein's equations to describe the universe, we get what's called a space-time manifold, essentially a map of all events that happen, have happened, and will happen. The whole history of the universe, from the Big Bang to the last black hole evaporating trillions of years from now, is laid out in this mathematical structure. The physicist Lee Smolin, who actually disagrees with the block universe view, admits that it's the dominant view in physics today. Most physicists working in relativity, cosmology, and fundamental physics accept that the block universe is the most straightforward interpretation of our best theories. But let's address the elephant in the room. If the future already exists, what about free will? What about choice? If everything is already determined, already existing in the block universe, then aren't we just actors reading a script that's already been written? Hold that thought, because we're going to come back to it in detail. But for now, let me plant a seed. Even in a block universe, your choices can still be real and meaningful. The fact that your choices exist in the block universe doesn't mean they weren't freely made. This is going to become clearer as we go deeper. Let me give you another analogy that might help. Think about a novel, a physical book sitting on a shelf. Every word, every sentence, every chapter exists simultaneously in that book. The ending is already there on the last page. But when you read the book, you experience it as a story unfolding in time. The characters make choices. Events happen. There's drama and uncertainty about what will happen next. The fact that the ending is already written doesn't make your experience of reading the story any less real. And from the perspective of the characters, if they were conscious, their choices would feel completely free to them, even though those choices are already written in the pages of the book. That's you in the block universe. Your entire life is already laid out in 4-dimensional spacetime. But your experience of that life, the subjective feeling of making choices and moving through time, is still completely real. It's just that this experience is itself part of the pattern in the block universe. The physicist Julian Barber takes this even further. He argues that time doesn't exist at all, not even as a dimension of the block universe. In his view, the universe is a vast space of possible configurations, and each configuration exists timelessly. What we perceive as time is just the relationship between these different configurations. But that's getting ahead of ourselves. We'll come back to Barber's ideas later. For now, the key point is this. According to our best physics, the future isn't something that's going to be created. It's something that already exists. You just haven't experienced it yet from your particular perspective moving through the block universe. And here's where it gets even weirder. If the future already exists, and in some sense, you're already dead. Your death is already there in the block universe, existing just as solidly as your birth and the moment you're experiencing right now. The you reading this right now is just one temporal slice of a larger 4-dimensional entity that includes your death. This should fundamentally change how you think about mortality. You're not going to cease to exist when you die. That moment of your death will exist forever in the block universe, just as every other moment of your life exists forever. In a strange way, you're immortal, not in the sense that you live forever, but in the sense that every moment of your life exists eternally in the structure of spacetime. Before we move on, take a second to let this sink in. Drop a comment with your reaction so far. Are you mind-blown? Skeptical? Existentially terrified? And if you haven't subscribed yet, what are you waiting for? This is just the beginning of how deep this rabbit hole goes. Okay, so if the block universe is real, If the past, present, and future all exist simultaneously, then we need to answer the most obvious question. Why does time feel like it flows? Why do we experience ourselves as moving from past through present into future if that movement isn't real? This is one of the biggest mysteries in physics and philosophy. It's called the problem of the arrow of time, or the problem of temporal experience. And I'm going to tell you right now, we don't have a complete answer, but we have some fascinating clues that are going to blow your mind. First, let's be clear about what needs explaining. You experience time as having a direction. You remember the past, but not the future. You can affect the future, but not the past. Causes come before effects. Eggs break, but don't spontaneously reassemble. Coffee and milk mix together, but never unmix. Stars form, burn, and die, never the reverse. All of these phenomena point to an arrow of time, a fundamental directionality to how events unfold. But here's the shocking thing. The fundamental laws of physics don't have this arrow. They're time symmetric. What does that mean? It means that if you filmed a movie of fundamental particles interacting, electrons, quarks, photons, and then played the movie backward, the backward version would show events that are just as consistent with the laws of physics as the forward version. At the fundamental level, physics doesn't distinguish between forward and backward in time. The physicist Richard Feynman, one of the pioneers of quantum electrodynamics, showed that you can think of an antiparticle as just a regular particle moving backward in time. The equations work perfectly, either way. Time symmetry is built into our most fundamental theories. So where does the arrow of time come from? Why does the universe seem to have a preferred direction if the fundamental laws are symmetric? The answer, or at least part of the answer, has to do with entropy. You've probably heard of entropy as disorder, but that's not quite right. Entropy is really a measure of the number of ways a system can be arranged, microscopically while still looking the same macroscopically. Here's an example. Imagine a room with all the air molecules bunched up in one corner. That's a low entropy state because there's only a very specific arrangement of molecules that produces that configuration. Now imagine the air molecules spread evenly throughout the room. That's a high entropy state because there are countless different arrangements of molecules that all look like evenly spread air. The second law of thermodynamics says that entropy tends to increase over time. Systems naturally evolve from low entropy states to high entropy states. Why? Simply because there are way more high entropy states than low entropy states. It's a statistics thing. If you have 1 trillion different ways to arrange molecules, and only 1,000 of those ways count as low entropy, then random changes are overwhelmingly likely to move you toward higher entropy. This is why eggs break but don't reassemble. A broken egg is a high entropy state. There are countless ways to arrange the molecules that all count as broken egg. An intact egg is a much lower entropy state. You need a very specific arrangement of molecules to get a functioning egg. So random molecular motions will naturally take an intact egg toward brokenness, but almost never take a broken egg toward intactness. And this is the arrow of time. Entropy increase gives us directionality. It's why causes precede effects, why we remember the past but not the future, why coffee and milk mix but don't unmix. But here's the mind-bending part. This arrow is entirely statistical. It emerges from the fact that there are more high-entropy states than low-entropy states. At the fundamental level, the laws of physics don't care which direction time points. The arrow of time is a feature of our macroscopic perspective, not a feature of fundamental reality. The physicist Sean Carroll, who's done extensive work on the arrow of time, puts it this way. The past is different from the future because the entropy was lower in the past. That's it. That's the whole answer. The directionality of time emerges from entropy gradients. But this raises an even bigger question. Why was entropy low in the past? Why did the universe start at the Big Bang in an incredibly low entropy state? This is one of the deepest unsolved problems in cosmology. The Big Bang was spectacularly unlikely from an entropy perspective. The early universe was in an extremely special, low-entropy configuration. All the matter and energy compressed into a tiny volume, highly ordered and uniform. Why? We don't know. Some physicists speculate about multiverse scenarios or quantum fluctuations. But honestly, we don't have a confirmed answer. What we do know is that because the universe started with low entropy, it's been increasing ever since. And it's this entropy increase that gives rise to the arrow of time, and ultimately to your subjective experience of time flowing. Now let's talk about the experience itself, the feeling of time passing, of being in the present moment, of moving from past into future. Where does that come from? This is where things get really speculative, but there are some intriguing ideas. One possibility is that consciousness has something to do with it. Your brain is a physical system processing information, and this processing has a natural direction determined by entropy increase. Your brain forms memories of low entropy states, the past, but can't form memories of high entropy states, the future, because the memory formation process itself increases entropy. So your subjective experience of now might be nothing more than the brain state you're currently in, processing information from previous lower entropy states and making predictions about future higher entropy states. The feeling of time flowing is just the feeling of information processing, happening in accordance with the arrow of entropy increase. The philosopher and cognitive scientist Thomas Metzinger argues that the now is a construction of your brain, a model that your mind builds to organize experience. In reality, neural processing takes time. When you see a flash of light and hear a sound at the same moment, your brain has to time adjust these signals because light travels faster than sound, and visual processing takes different amounts of time than auditory processing. Your brain creates a unified present moment, even though the actual processing of these signals happens across a span of time and has to be retrospectively synchronized. So now isn't a fundamental feature of reality, it's a feature of your conscious experience, created by your brain to help you navigate the world effectively. Think of it like this. You're watching a movie on a screen. The movie is stored on a hard drive where all the frames exist simultaneously. Your experience of the movie playing, of time passing within the movie, is created by your visual system processing frames in sequence. The flow of the movie isn't in the hard drive, it's in the processing. Similarly, the flow of time isn't in the universe, it's in your experience, created by your brain processing information in accordance with entropy gradients in a block universe where everything already exists. This is what the physicist Carlo Rovelli means when he says, time is a local phenomenon. Time flows differently for different physical systems, and there is no universal time. Your experience of time is tied to your physical state, your motion, your position in a gravitational field, and the information processing architecture of your brain. The now you're experiencing right now exists, but it's not a global feature of the universe. It's a local feature of your perspective as you trace your path through the block universe. If this is making your head hurt, good. That means you're really grappling with the implications. Because what we're arriving at is this: the passage of time is an illusion. Not in the sense that your experience is fake, your experience is completely real. But your experience doesn't reflect an objective feature of the universe. Time doesn't actually pass in reality. You just experience the static structure of the block universe in a particular way that creates the illusion of flow. So far, we've talked mostly about relativity and the block universe. But there's another fundamental theory of physics that we need to talk about: quantum mechanics. And when you bring quantum mechanics into the picture, the nature of time becomes even stranger. Quantum mechanics is the physics of the very small atoms, electrons, photons, and it's weird. Deeply, fundamentally weird in ways that challenge our basic intuitions about reality. One of the most famous features of quantum mechanics is superposition. Before you measure a quantum system, it exists in a superposition of multiple states simultaneously. An electron doesn't have a definite position until you measure it. It's spread out in a probability cloud of all possible positions. Schrodinger's cat, before you open the box, is both alive and dead simultaneously. This has been confirmed experimentally countless times. In the famous double-slit experiment, an electron behaves like it goes through both slits at once when you're not watching, creating an interference pattern. But if you measure which slit it goes through, the interference pattern disappears and the electron behaves like it went through one slit or the other. Now, what does this have to do with time? Well, here's the crazy part. Superposition applies to time as well as space. In 2014, physicist Magdalena Zeitsch and her colleagues at the University of Vienna and the University of Queensland performed an experiment with a quantum clock in superposition. They showed that a quantum system can exist in a superposition of different times, experiencing multiple temporal evolutions simultaneously until it's measured. Think about what that means. It's not just that we're uncertain about what time it is for the quantum system. The system is actually in multiple time states at once until you measure it. Time itself becomes quantum, subject to superposition. This raises mind-bending questions about the nature of time in a quantum universe. If quantum systems can exist in superpositions of different temporal states, what does that mean for the arrow of time? What does it mean for causality? Some physicists, like the theoretical physicist Lee Smolin, argue that quantum mechanics suggests time might be more fundamental than we thought, that time is real and the block universe picture is wrong. In Smolin's view, quantum uncertainty means the future genuinely doesn't exist yet. It's created moment by moment as quantum superpositions collapse into definite states. But other physicists disagree. The physicist Sean Carroll argues that quantum mechanics can be perfectly consistent with the block universe through something called the many worlds interpretation. In this view, quantum superpositions never actually collapse. Instead, every time a quantum measurement happens, the universe splits into multiple branches, with each possible outcome occurring in a different branch. In the many worlds picture, the block universe isn't just four-dimensional. It's an enormously complex branching structure where every quantum possibility is realized in some branch. Your future doesn't just already exist, it exists in countless variations, one for each possible outcome of every quantum event. Let me put this in perspective for you. Every time a particle in your brain could go one way or another based on quantum randomness, the universe splits. In one branch, it goes left. In another branch, it goes right. This is happening trillions of times per second throughout your brain, which means there are an almost infinite number of yous existing in parallel branches of the quantum multiverse, each experiencing slightly different versions of what you think of as now. The physicist Max Tegmark calculated that there are about 10 to the power of 115 different branches of the quantum multiverse arising just from the quantum states in your brain over the course of your lifetime. That's a number so large that it's meaningless more branches than atoms in the observable universe raised to the power of atoms in the observable universe, many times over. And in the many worlds block universe, all of these branches exist simultaneously. Your future isn't just one thing, it's a vast tree of possibilities, all already existing in the quantum spacetime structure. Now, whether the many worlds interpretation is correct is still debated. There are other interpretations of quantum mechanics, like the Copenhagen interpretation or objective collapse theories, that give different pictures of reality. But the point is this: however you interpret quantum mechanics, it makes the nature of time even more bizarre than relativity alone suggests. Let me give you another quantum time weirdness to think about. In quantum mechanics, there's something called retrocausality, or backwards causation. In certain experiments, it looks like the future can affect the past. The most famous example is Wheeler's delayed choice experiment, proposed by physicist John Wheeler in 1978 and actually performed in laboratories since then. In this experiment, you can choose whether to measure a photon as a wave or a particle after it's already passed through a double slit. Your choice seems to retroactively determine how the photon behaved earlier, whether it went through both slits as a wave or just one slit as a particle. Now, most physicists don't interpret this as literal backwards causation in time. Instead, they interpret it as showing that quantum systems don't have definite properties until they're measured, regardless of when the measurement happens relative to when the system was created. But it definitely challenges our normal notions of cause and effect, past and future. The physicist Hugh Price at Cambridge has argued that quantum mechanics might require us to think of causation as fundamentally time-symmetric causes can influence their effects, and effects can influence their causes, with no preferred direction. This would be consistent with the time symmetry of the fundamental laws, but it's completely at odds with our everyday experience. There's also something called quantum entanglement that messes with our notions of time and space. When two particles are entangled, measuring one instantaneously affects the other, no matter how far apart they are. Einstein called this spooky action at a distance, and it bothered him because it seems to violate the principle that nothing can travel faster than light. But experiments have confirmed entanglement countless times. In 2017, physicists used entangled photons from sources 1,200 kilometers apart and showed that the correlation between them couldn't be explained by any local hidden variables. The correlation is instantaneous across space. But instantaneous in relativity depends on your frame of reference. What's instantaneous for one observer might not be for another. So quantum entanglement seems to contradict the relativity of simultaneity we talked about earlier. Reconciling quantum mechanics with general relativity is one of the biggest unsolved problems in physics. We don't have a complete theory of quantum gravity yet, but whatever the final theory looks like, it's going to have to explain time in a way that's consistent with both quantum weirdness and relativistic spacetime geometry. Some approaches to quantum gravity, like loop quantum gravity or causal set theory, suggest that spacetime itself is granular at the smallest scales made up of discrete chunks rather than being continuous. If that's true, then time might have a smallest possible unit, a quantum of time around 10 to the minus 43 seconds, the Planck time. Below that scale, the very notion of before and after might break down completely. Other approaches, like string theory, require additional dimensions of space beyond the three we experience. Some versions of string theory have been interpreted as suggesting that time might be emergent, not a fundamental feature of reality, but something that emerges from more fundamental, timeless quantum states. The physicist Julian Barber, who I mentioned earlier, has developed an approach called timeless physics, where the fundamental laws operate on a space of possible configurations with no reference to time at all. In Barber's view, time is completely emergent from correlations between configurations. The universe doesn't evolve in time. Rather, different configurations exist timelessly, and some of these configurations contain records that create the illusion of a history. All of these ideas are speculative. We don't yet know which approach to quantum gravity will turn out to be correct. But they all suggest that at the deepest level, time might not be what we think it is. It might be emergent, granular, multidimensional, or even completely illusory. And here's what should really blow your mind. All of this quantum weirdness is happening right now in your brain. Your thoughts, your consciousness, your subjective experience of time, all of it is ultimately built on quantum processes in neurons and synapses. The quantum superpositions, the entanglements, the measurement problems, they're all relevant to how your brain creates your experience of reality. Some researchers, like the physicist Roger Penrose and the anesthesiologist Stuart Hameroff, have even proposed that consciousness itself might be a quantum phenomenon, arising from quantum processes in structures called microtubules inside neurons. This is controversial and not widely accepted, but it's an active area of research. The point is, the weirdness of quantum time isn't some abstract thing happening in laboratories. It's happening in you right now as you read these words. Let's take everything we've learned so far and really drive home what it means for your experience of the present moment. Right now, you feel like you're in the present. You feel like there's this moment now that's special. That's real in a way the past and future aren't. The past is gone. The future hasn't happened yet, but now is real. That's the natural, intuitive way to think about time. But according to physics, that intuition is wrong. Completely, totally wrong. There is no special present moment. There is no now that sweeps through the universe, transforming future into past. The present moment is not a fundamental feature of reality. It's a feature of your perspective. Let me hammer this home with an example. Imagine an alien on a planet 1 billion light years away. Because light takes 1 billion years to travel from there to here, when we look at that planet with a telescope, we're seeing what happened there 1 billion years ago. Their past is what we're seeing now. But here's the thing. According to relativity, if that alien is moving toward us at a high speed, their now, what counts as the present moment for them, might include events on Earth that are in our past. And if they're moving away from us, their now might include events in our future. This isn't just about perception or the travel time of light. This is about what actually counts as simultaneous. The relativity of simultaneity means there's no fact of the matter about what's happening now across the universe. Different observers have different nows, and they're all equally valid. The philosopher of physics, David Hilbert, puts it this way. The distinction between past, present, and future is only a stubbornly persistent illusion. That's a quote from Einstein, actually from a letter he wrote to comfort the widow of his friend Michel Bessot. Einstein wrote, "People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion." Think about what that means for your life. Every moment you've ever experienced, every moment you're experiencing now, every moment you will ever experience, they're all equally real. They all exist in the block universe. Your 5th birthday party, your high school graduation, your first kiss, the moment you're experiencing right now reading these words, your last conscious thought before you die, they're all out there in space-time, existing simultaneously. You think you're moving from past into future, experiencing new moments as you go, but really, you're not moving at all. You're a static 4-dimensional structure in space-time, and each cross-section of that structure has the subjective experience of being now, and of having memories of past slices and uncertainty about future slices. But from outside the block universe, from what philosophers call the God's eye view, it's all just there, laid out with no privileged present moment. The philosopher J.M.E. McTaggart made a famous argument in 1908 that time is unreal. He distinguished between 2 ways of thinking about time, which he called the A series and the B series. The A series is time as we experience it. Events are past, present, or future, and these properties change. An event that's future becomes present, then becomes past. This is the tensed view of time, where the present moment is special and moves forward. The B series is time as physics describes it. Events are earlier or later than each other, but there's no objective now that moves. This is the tenseless view of time. Events don't change from being future to being past. They just have fixed temporal relations to each other. McTaggart argued that the A series leads to contradictions, and therefore, time must be unreal. But modern physics suggests something slightly different. The A series is psychologically real, but not physically real. The B series is how time actually is in the physical universe. Your subjective experience of time, your feeling of being in a moving now, is real as an experience. It's not an illusion in the sense of being false. You really do have that experience. But it doesn't correspond to any objective feature of the physical universe. It's a feature of your perspective, like how the sun appears to move across the sky, even though it's really Earth rotating. Here's an analogy that might help. Think about the horizon. When you look around, you see a circle where the sky meets the land or sea. That horizon seems like a real thing, a real boundary in the world. And in a sense, it is real, you really do see it, and you can point to it and measure it. But the horizon isn't a physical object out there in the world. It's a feature of your perspective. It's the limit of what you can see from where you're standing. Someone standing somewhere else would have a different horizon. An observer floating in space would have no horizon at all. The present moment is like that. It's the temporal horizon of your experience, the limit of what you can directly perceive from your position in spacetime. It's real as an experience, but it's not a physical thing out there in the universe. It's a feature of your perspective. And just like how someone standing on a mountain has a more distant horizon than someone standing on flat ground, different observers in different states of motion or different gravitational fields have different present moments. Their temporal horizons are in different places in spacetime. Now, you might be thinking, but wait, things do change. I can see things changing right in front of me. A candle burns down, a flower wilts, I'm getting older. How can you say time isn't real when change is so obvious? Here's the subtle point. Change is real within time. As you move along your world line through spacetime, you encounter different configurations of matter and energy. Relative to your earlier self, your later self is different. That's change. But the block universe contains all of these different configurations simultaneously. The candle at every stage of burning exists in the block universe. You at every age exist in the block universe. Change is the difference between one temporal slice of the universe and another temporal slice. It's real in the sense that different slices are genuinely different from each other. But there's no sense in which one slice is more real than another, or in which slices are being created as time moves forward. All the slices exist simultaneously in the block. Think of it like a movie again. In the movie, characters age, objects change, events happen. There's genuine change in the content of the movie from beginning to end. But the entire movie exists simultaneously on the DVD. The change within the movie doesn't mean the DVD is changing. The DVD just contains all the different frames, each showing a different state of affairs. And when you watch them in sequence, you perceive change. You're like someone watching that movie from the inside, experiencing frame by frame, unable to see that all the frames exist simultaneously on the disc. The physicist Paul Davies puts it this way: the passage of time is a meaningful concept for us because we are embedded in time, with records of the past, but not the future. But that doesn't mean time really passes in any absolute sense. Before we move on, I want you to really sit with this idea. Close your eyes for a moment after reading this paragraph. Think about the present moment you're experiencing. That feeling of nowness is completely real as an experience. But it's not a feature of the universe. It's a feature of you, of your particular path through spacetime, of your brain processing information in accordance with entropy gradients. The universe doesn't have a present moment. You do. All right, we've established that according to modern physics, the future already exists, and the present moment is not an objective feature of reality. Now we need to tackle the big question. What does this mean for free will? What does it mean for causality? If everything is already laid out in the block universe, are we just following a predetermined script? This is where a lot of people get uncomfortable, and I understand why. The idea that your future is already written seems to undermine everything we believe about choice, responsibility, and the meaning of our actions. But here's the thing. Even in a block universe, your choices are still real. Let me explain why. First, let's be clear about what determinism means. Determinism is the idea that the future is fully determined by the past, plus the laws of nature. If you knew the exact state of every particle in the universe and all the laws of physics, you could in principle calculate what will happen in the future. Many physical theories are deterministic. Classical mechanics is deterministic if you know the positions and velocities of all particles. Newton's laws tell you exactly where they'll be at any future time. General relativity is deterministic in most circumstances. Even some interpretations of quantum mechanics, like the many worlds interpretation, are deterministic. But here's the crucial point. Determinism doesn't mean you don't have free will. It just means your free choices are part of the determined structure of the universe. Think about it this way. When you make a choice, let's say you're choosing what to eat for lunch. Your brain is in a certain state, processing information, weighing options, considering factors like health, taste, convenience. That process of deliberation is real. It's a physical process happening in your brain. And the output of that process, your choice, is also real. Now, in a deterministic block universe, that choice was always going to happen. Given your brain state, your memories, your preferences, the sensory input you're receiving, the choice was determined. But that doesn't make it any less your choice. You went through the deliberation process. You weighed the options. You made the decision. The philosopher Daniel Dennett calls this compatibilism, a view that free will is compatible with determinism. In Dennett's view, free will isn't about being undetermined or random. It's about making choices based on your own reasons, your own values, your own deliberative process. As long as you're the one doing the choosing, as long as your brain is running the decision-making algorithm, your choices are free, even if they're determined. Think about it this way. If your choices were random, would that make you more free? If a cosmic coin flip decided what you eat for lunch, would that be free will? No, because it's not you making the choice, it's randomness. Free will isn't about indeterminacy. It's about self-determination. And in the block universe, your choices are still self-determined. Yes, those choices exist in the block universe. Yes, they were always going to happen. But they happen because of you, because of your brain, your reasoning, your values. The fact that they're part of the pre-existing structure of spacetime doesn't make them any less yours. Here's another way to think about it. The future exists, but it exists in a way that includes your choices. It's not like there's a future that's laid out, and then you come along and fail to change it because it's already determined. No, the future that exists includes you making the choices you make. Your choices are part of what makes the future what it is. The physicist Sean Carroll puts it this way: we are part of the universe. We don't stand outside it, able to choose this future or that future. We're patterns of atoms obeying the laws of physics, and our choices are part of that pattern. But they're still genuinely our choices. Now, there's a subtlety here related to quantum mechanics. If quantum mechanics is truly indeterministic, if quantum events are genuinely random rather than just apparently random, then the future might not be fully determined by the past. In that case, the block universe would be a branching structure, as in many worlds. Or the future might not exist yet at all, as some physicists argue. But either way, your choices are still real. If quantum randomness exists and plays a role in brain function, that randomness doesn't give you free will. Randomness isn't freedom. What gives you free will is being able to make choices based on reasons, values, and deliberation. And that's still possible in either a deterministic block universe or an indeterministic branching universe. Let's talk about causality now. In our everyday experience, causes come before effects. You flip a light switch, cause, and the light turns on, effect. You drop a glass, cause, and it breaks, effect. This seems obvious and fundamental, but in the block universe, the relationship between cause and effect is more subtle. All events exist simultaneously in spacetime. The cause and the effect both exist. So what makes one the cause and the other the effect? The answer has to do with entropy again. Causality follows the arrow of time, which is defined by entropy increase. We call event A the cause of event B when event A is at a lower entropy and event B is at higher entropy. And there's a physical connection between them such that the occurrence of A raises the probability of B. But this causal relationship is baked into the structure of the block universe. Event A doesn't cause event B in the sense of making it happen. Both events already exist in the block. Rather, the events are arranged in spacetime in such a way that we recognize a causal relationship between them. Think of it like a movie again. In the movie, one scene causes another character, makes a decision that leads to consequences later. But all the scenes exist simultaneously on the DVD. The causal relationship is in the content of the scenes, not in some external process of one scene creating another. That's how causality works in the block universe. Causal relationships exist as patterns in how events are arranged in spacetime. Causes don't create effects. Causes and effects coexist as causally related events in the block. This might seem like a philosophical distinction without a difference, but it has profound implications. It means that the future doesn't affect the past, not because the future doesn't exist yet, but because of the arrangement of events in spacetime follows entropy gradients that create an arrow of time. In principle, there could be regions of spacetime where entropy decreases instead of increases, and in those regions, causality would run backward. This is purely hypothetical. We don't observe such regions, but it's allowed by the fundamental laws of physics. Causality is not a fundamental feature of physical law. It's an emergent feature of entropy gradients. Now let's talk about something even weirder. What if the past isn't as fixed as we think? What if the block universe allows for something like changing the past? This is going to sound like science fiction, but there are serious physicists who study closed time-like curves paths through spacetime that loop back on themselves, allowing a traveler to return to their own past. These arise as solutions to Einstein's equations under certain exotic conditions. The physicist Kip Thorne, who won the Nobel Prize for his work on gravitational waves, has shown that wormholes, if they exist, could potentially be used as time machines. You'd go in one end and come out the other end at an earlier time. This would create a closed time-like curve. Now, do such things actually exist in our universe? Almost certainly not. They require exotic matter with negative energy density, which may not exist. And even if they do exist, there are paradoxes like the grandfather paradox, where you go back in time and prevent your own birth. But here's what's fascinating. The existence of closed time-like curves in the mathematical structure of general relativity tells us something profound about time. It tells us that time isn't necessarily linear. The topology of spacetime could allow loops. And if time can loop, then the distinction between past, present, and future becomes even more blurred. In a region of spacetime with closed time-like curves, an event could be both in your past and in your future simultaneously. You could attend your own birth. You could be your own grandfather. These scenarios create paradoxes, and physicists debate whether the laws of physics would prevent them from actually occurring. The chronology protection conjecture, proposed by Stephen Hawking, suggests that quantum effects would prevent closed time-like curves from forming, but we don't know for sure. The point is, our intuitive notions of past, present, and future, of cause and effect, of free will and determinism, all of these are much more complicated and much less clear-cut than they seem. The universe, according to our best physics, is far stranger than common sense suggests. And you, yes, you, sitting there reading this, are part of that strange universe. Your choices, your experiences, your life, they're all threads woven into the four-dimensional tapestry of spacetime. They exist, they're real, they matter. But they exist in a way that's completely different from how you've always imagined. Take a moment to let this sink in. If you're finding this challenging, that's normal. These ideas challenge our deepest intuitions, but that's what makes them so profound. We're not just learning facts here, we're restructuring our entire conceptual framework for understanding reality. All right, We're about halfway through this journey, and your brain is probably hurting. That's good. That means you're really engaging with these ideas. But now I want to shift gears a bit and talk about what all of this means for you, personally, in your everyday life. Because here's the thing, even if the block universe is true, even if time doesn't flow, even if the future already exists, you still have to live your life. You still wake up in the morning, make decisions, pursue goals, experience emotions. So how do you integrate this understanding into your actual lived experience? First, let's talk about mortality. If the block universe is real, then in a profound sense, you're immortal. Not in the sense that you never die, you do die, and that moment of death exists in the block universe. But every moment of your life exists eternally in space-time. You at age 5, you right now, you on your deathbed. All of these yous exist forever as part of the structure of space-time. The physicist Carlo Rovelli says it beautifully. To the question, what is reality? There is only one answer that makes sense. Reality is what's invariant. What doesn't depend on the arbitrary choices of how we decide to observe it. And the past doesn't disappear. Your childhood exists. It's not gone, it's still out there in space-time. Think about what this means. Every beautiful moment you've ever experienced, every sunset you've watched, every time you've laughed with friends, every moment of love, those moments still exist. They're not gone. They're eternal parts of the structure of space-time. In a real sense, they're always happening. And the same is true for the painful moments. Every loss, every heartbreak, every moment of suffering, those exist too, eternally. You can't escape them, but you also can't lose them. They're part of your four-dimensional self. This can be profoundly comforting or profoundly disturbing, depending on how you look at it. For me, it's both. The idea that my loved ones who have died still exist, that the moments I shared with them are eternal parts of space-time, brings comfort. But the idea that every painful experience I've ever had is also eternal, always there in the block universe, is harder to accept. The key, I think, is to realize that you, the you that's experiencing this present moment, are just one slice of your complete four-dimensional self. Yes, the painful moments exist, but so do moments of recovery, healing, and growth. Yes, you die, but you also live. The entirety of your life is the sum of all these moments, and they're all equally real. The philosopher Hugh Price suggests we should think of ourselves as four-dimensional worms extending through space-time. You're not a three-dimensional object moving through time. You're a four-dimensional object that exists across time. Just as your body extends in 3 spatial dimensions, you extend in the temporal dimension too. And here's what's wild. The you that exists at different times are, in some sense, different people. The you at age 5 had different beliefs, different memories, different personality traits than the you right now. The you 10 years from now will be different again. You're not a single, unchanging entity, you're a process. A pattern that evolves along your world line through space-time. The philosopher Derek Parfit wrote extensively about personal identity and came to the conclusion that what we think of as a self is really just a series of connected mental states. There's continuity. Each moment of you is connected to the previous moment through memory and physical causality, but there's no unchanging essence that makes you you. In the block universe picture, this makes even more sense. You're not a single thing moving through time. You're a four-dimensional structure in space-time, and each cross-section of that structure is a different version of you, all equally real, all existing simultaneously. This has profound implications for how you think about your choices and your future. When you make a decision now, it affects your future. When you study for an exam, start exercising, quit a bad habit, pursue a relationship, you're not changing what will happen. The future you is already there in the block universe, but you are determining what that future you is like. Your choices now are constitutive of your future self in the block universe. Think of it this way. Imagine you're looking at a map of a journey. The entire route is laid out. You can see the starting point, the destination, and all the twists and turns in between. The journey is, in a sense, already there on the map. But the reason the journey goes this way, and not that way, is because of the choices made along the route. The choices are part of what makes the journey what it is. Your life is like that. It's already laid out in space-time, but the choices you make are part of what makes it that particular trajectory through space-time. You're not changing the future, you're being yourself, and yourself includes your future. This might seem like a subtle distinction, but it's important. It means your choices matter. They matter not because they change a future that would otherwise be different, but because they're constitutive of what your life is. You are your choices. Your life is shaped by your decisions. And that's true even in a block universe. Now let's talk about regret and what-ifs. If the block universe is real, then there's no alternate timeline where you made different choices. The choice you made is the choice that exists in the block universe. So does it make sense to regret your past decisions? In one sense, no. You can't change the past. It exists in the block universe just as surely as the present does. Wishing you had made different choices is like wishing you were taller or had been born in a different country. It's wishing for a different person, a different world line through space-time. But in another sense, regret still makes sense. Regret is a feeling that arises from recognizing that you could have acted in accordance with your values but didn't. It's a recognition of the gap between who you are and who you want to be. And that recognition can motivate change in your future behavior. The key is to not get stuck in regret. Yes, the choices you made in the past are part of your four-dimensional self and can't be changed. But your future, which already exists, but which you haven't experienced yet, is also part of your four-dimensional self. And you get to determine what that future is like through your choices now. The philosopher Robert Nozick suggested that we should think of our lives as works of art that we're creating. The block universe is the canvas on which your life is painted. You don't get to choose which canvas you're on or where you started painting, but you do get to make the brush strokes. And those brush strokes matter, even if the painting as a whole already exists. Let's talk about anticipation and excitement for the future. If the future already exists, does it make sense to look forward to things? To be excited about an upcoming vacation or a future achievement? Absolutely. The fact that a future event already exists in the block universe doesn't make your experience of anticipation any less real or any less meaningful. Anticipation is part of how you experience your journey through space-time. It's part of the richness of your subjective experience. Think of it like reading a mystery novel. Even if the ending is already written, you can still experience suspense and excitement as you read. Your not knowing how it ends creates genuine anticipation, even though the words on the page don't change based on whether you've read them yet. Your life is similar. Future events exist in the block universe, but you haven't experienced them yet from your perspective. So anticipation and excitement are appropriate responses. They're part of how you, as a conscious being moving along your world line, experience the structure of space-time. The key insight is this: the block universe doesn't negate your experience. It explains your experience. Your feelings of anticipation, your sense of free will, your memories of the past, all of these are real features of your subjective experience, and they arise from your particular perspective as a conscious entity moving through the block universe along the arrow of entropy increase. You're not separate from the universe, looking at it from the outside. You're part of the universe, embedded in it, experiencing it from within. And that experience is as real as anything else in the universe. Before we move on, take a moment to reflect on your own relationship with time. How do you feel about your past, your present, your future? Does thinking about the block universe change how you relate to these? Drop your thoughts in the comments. I'm genuinely curious about how this material is landing for different people. And hey, if you're still with me after almost an hour and a half, you deserve a medal. Make sure you've liked this video and subscribed. because we're about to go even deeper. We've talked a lot about physics and time, but we haven't really addressed the elephant in the room: consciousness. Your subjective experience. The fact that it feels like something to be you. Because here's the mystery. We can describe the block universe. We can write down the equations of physics. We can explain the arrow of time in terms of entropy. But none of that explains why you have a subjective experience at all. Why does it feel like something to be a conscious being moving through spacetime? Why are you aware? This is called the hard problem of consciousness, a term coined by philosopher David Chalmers in 1995. The hard problem is explaining why physical processes in the brain give rise to subjective experience, what philosophers call qualia. Why does seeing the color red feel like something? Why does pain hurt? Why is there something it's like to be you? And related to time, why do you experience yourself as existing in a present moment that moves forward? Where does the feeling of now come from? We don't have complete answers to these questions. Consciousness remains one of the deepest mysteries in science. But there are some fascinating theories that connect consciousness to the nature of time. One idea, proposed by Giulio Tononi and others, is called Integrated Information Theory, IIT. According to IIT, consciousness is a measure of how much information is integrated in a system. Your brain integrates vast amounts of information from different sensory inputs, memories, and cognitive processes. The more integrated this information is, the more conscious the system is. In the IIT framework, your experience of now might be the subjective feel of information integration happening in your brain. At each moment, your brain is taking in sensory data, accessing memories, running cognitive processes, and integrating all of this into a unified experience. That integration process has a particular feel to it from the inside, and that feel is what you experience as the present moment. Different moments of information integration would feel like different nows, creating the illusion of time flowing as you move from one state of integration to the next along your world line. Another theory connects consciousness to quantum mechanics. The physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed that consciousness arises from quantum processes in microtubules protein structures inside neurons. In their view, consciousness involves quantum superposition and collapse in the brain. This is highly speculative and controversial. Most neuroscientists are skeptical that quantum effects play a significant role in brain function because the brain is too warm and noisy for delicate quantum states to survive. But if Penrose and Hameroff are right, then consciousness might be fundamentally quantum in nature. And if consciousness is quantum, then it might experience time in a fundamentally different way in classical objects. Remember how we talked about quantum systems existing in superpositions of different time states? If consciousness is quantum, maybe your experience of now is a quantum phenomenon, a collapse of temporal superposition into a definite moment of experience. Again, this is speculative, but it's an example of how consciousness might be deeply connected to the fundamental nature of time at the quantum level. There's also a theory proposed by philosopher Thomas Metzinger that consciousness creates a self-model, a model of yourself as an agent existing in a present moment, with a past behind you and a future ahead of you. According to Metzinger, the self is a construction, a useful fiction that your brain creates to help you navigate the world. In Metzinger's view, there's no real you that persists through time. There's just a continuous process of the brain creating and updating a self-model. The feeling of being a unified self existing in a present moment is part of this model. It's not illusory in the sense of being false. You really do experience it. But it's a construction, not a fundamental feature of reality. This ties into the block universe picture beautifully. In the block universe, there is no privileged present moment. But your brain, as it processes information along your world line, creates the experience of a present moment as part of its self-model. The now is generated by your brain to organize your experience, even though it doesn't correspond to any objective feature of spacetime. Think of it like a video game. In a video game, you see the world from a first-person or third-person perspective. The graphics render what's around you in the game world, but the entire game world exists on the computer's hard drive. The perspective you see is generated by the graphics engine to give you a useful view of the game state. Your brain does something similar, generating a perspective of a present moment to give you a useful experience of your state in the block universe. Now, here's something that will really mess with your head. If consciousness is what creates the experience of now, then different conscious beings might have different nows, not just because they're in different states of motion, but because they're having different subjective experiences. Your experience of now is tied to your particular brain state, your particular pattern of information integration, your particular quantum state, if quantum consciousness theories are correct. Someone else's experience of now is tied to their brain state. Even if you're sitting right next to each other, your subjective nows might be slightly offset because your brains are processing information at slightly different rates or in slightly different ways. This gets even weirder when you think about non-human consciousness. Does a dog experience now the same way you do? Probably not. Their cognitive architecture is different. Their sensory processing is different. Their sense of time might be compressed or expanded relative to yours. What about an octopus, whose neurons are distributed throughout its body, including in its arms? What about potential alien intelligences or future AI systems? Each conscious entity might have its own unique experience of temporality, its own subjective now, its own way of experiencing the passage of time. There might not be one phenomenology of time. There might be countless different ways of experiencing time, depending on the structure of the conscious system. The philosopher Thomas Nagel wrote a famous paper titled, "What is it like to be a bat?" arguing that we can't really know what a bat's subjective experience is like because their sensory modalities, echolocation, and cognitive architecture are so different from ours. The same is true for temporal experience. We can't really know what time feels like to a dog or an octopus or an alien. We only know what it feels like to us. And here's the really mind-blowing implication. If consciousness is what generates the experience of time flowing, then maybe, just maybe, there could be conscious experiences that don't involve time at all. Some mystics and meditators report experiences of timelessness during deep meditation or psychedelic experiences, states of consciousness, where the normal feeling of time passing dissolves. They describe these states as feeling like being outside of time, or experiencing all moments at once, or accessing a realm beyond time. Are these experiences revealing something true about the nature of consciousness and time? Or are they just disruptions of the normal cognitive processes that create temporal experience? We don't know, but they're consistent with the idea that temporal experience is a construction of consciousness, rather than a fundamental feature of reality. The neuroscientist Anil Seth has done research showing that your brain actively predicts and constructs your experience of time. When your brain is expecting something, time seems to pass slowly. When you're surprised, time seems to jump. Your experience of duration is flexible and constructed based on your brain's predictive models. Seth argues that all perception is controlled hallucination. Your brain generates a model of reality based on sensory input and prior expectations. You're not directly perceiving reality. You're perceiving your brain's best guess about reality, and that includes your perception of time. So the flow of time might literally be a hallucination, not in the sense that it's not real to you, but in the sense that it's generated by your brain rather than being a direct perception of an objective feature of the universe. Let me put this all together. You are a conscious being embedded in a block universe. Your consciousness arises from physical processes in your brain, whether classical, quantum, or some combination. As your brain processes information along your world line through spacetime, it generates a subjective experience of being in a present moment that moves forward. This experience is real as an experience, but it doesn't reflect an objective now or an objective flow in the universe. It's how the universe feels from the inside when you're a conscious entity with your particular cognitive architecture. And here's what's beautiful about this. Your consciousness, your subjective experience, is the universe's way of experiencing itself. You're not separate from the universe, observing it from outside. You're a pattern in the universe that's complex enough to be aware of itself. You're the universe looking at itself through your particular perspective. The physicist Carl Sagan said it beautifully. We are a way for the cosmos to know itself. Your consciousness is a window through which the block universe experiences a slice of itself, creating the illusion of flow, the feeling of now, the drama of choices and consequences. You are, in the most literal sense, the universe becoming aware of its own existence. And that awareness necessarily involves experiencing yourself as located in time, even though from the God's eye view, all of time exists simultaneously. Now, I've been presenting the block universe as if it's the consensus view in physics. And to some extent, it's the most straightforward interpretation of relativity. But I want to be intellectually honest with you. Not all physicists accept it. There are alternative views, and there are serious objections to the block universe that we need to address. Let's start with the objections from physics itself. Some physicists argue that quantum mechanics is incompatible with the block universe. We talked earlier about how superposition complicates things, but let's dig deeper. The physicist Lee Smolin has been one of the most vocal critics of the block universe. In his book, Time Reborn, Smolin argues that time is fundamental and real more fundamental than space, even. He thinks the block universe picture makes a mistake by treating time as just another dimension like space. Smolin's argument goes like this. In quantum mechanics, the future is not determined until measurements happen. Before a measurement, a quantum system is in a superposition of possibilities. The measurement causes the superposition to collapse into one definite outcome. If this collapse is a real physical process, not just a change in our knowledge, then the future is genuinely created moment by moment as quantum collapses happen. In this view, the present moment is the boundary between the fixed past, which has already undergone quantum collapse, and the open future, which exists as a range of quantum possibilities. Only the present moment is fully real. The past is real in the sense that it's recorded in the present state of the universe. The future is not real yet. It's potential, but not actual. Smolin argues that we need a new theory of quantum gravity that takes time seriously as fundamental. He's working on an approach called causal set theory, where spacetime is built up from discrete causal events, and time has a fundamental directionality built in. Another critic is the philosopher Tim Maudlin, who argues that the passage of time is real and fundamental. Maudlin says that physics should explain our experience of time passing, not dismiss it as an illusion. He thinks the block universe picture confuses a mathematical representation of reality with reality itself. Maudlin's view is that the equations of physics describe reality, but they're not identical to reality. Just because we can write down a four-dimensional mathematical structure representing spacetime doesn't mean spacetime actually is a static four-dimensional block. The math might just be a useful tool for making predictions while missing something essential about the nature of time. There's also an objection from thermodynamics. We explained the arrow of time as coming from entropy increase, but why does entropy increase? Why did the universe start in a low entropy state at the Big Bang? This is the past hypothesis, and we don't have a good explanation for it. If we can't explain why entropy increases, if it's just a brute fact about initial conditions, then maybe that's pointing to something fundamental about time that the block universe picture is missing. Maybe time really does flow, and entropy increase is a manifestation of that flow, rather than an explanation of it. Some physicists have proposed that the arrow of time might be connected to the expansion of the universe. The universe is expanding, getting bigger over time. Maybe this expansion is what gives time its directionality. In this view, time flows because space is growing. If the universe stopped expanding or started contracting, maybe time would stop or reverse. This is speculative, but it's an example of how the arrow of time might be connected to something more fundamental than just entropy. There are also objections from philosophy. The philosopher Dean Zimmerman argues for presentism, a view that only the present moment exists. The past did exist, but doesn't anymore. The future will exist, but doesn't yet. Right now, only now is real. Zimmerman admits that presentism is hard to reconcile with relativity, but he argues that we might need to modify our physics to accommodate the reality of temporal passage. Maybe relativity is true as a practical theory for making predictions, but it doesn't give us the complete metaphysical picture of reality. Another philosophical objection comes from the phenomenology tradition. Philosophers like Edmund Husserl and Martin Heidegger argued that our experience of time is primary and fundamental. We shouldn't start with physics and then try to explain consciousness. We should start with consciousness and build our understanding of reality from there. From a phenomenological perspective, the flow of time and the reality of the present moment are given directly in experience. They're more certain than any physical theory. So if physics tells us time doesn't flow, maybe that's a problem with physics, not with our experience. The philosopher Hugh Price, though, offers a middle ground. Price accepts the block universe, but argues that it's compatible with the reality of our temporal experience. In his view, we need two perspectives: the view from no one, the objective, timeless description of the block universe, and the view from now, our subjective, time-bound perspective within the universe. Both perspectives are real and valid. Physics gives us the view from no one. Consciousness gives us the view from now. Neither is more fundamental than the other. They're just different ways of describing the same reality. I find Price's view compelling because it doesn't dismiss either physics or experience. It takes both seriously and tries to show how they fit together. Now let's address a different kind of objection, the meaning objection. If the future already exists, if your life is already laid out in the block universe, doesn't that make everything meaningless? If you're just following a predetermined path, why bother trying to do anything? This objection misunderstands what it means for the future to exist in the block universe. Yes, your future is already there, but it's there because of your choices. You're not following a path that was laid out independent of you. You are the path. Your choices constitute your world line through spacetime. Think of it this way. A novel's ending already exists on the last page, but that doesn't make the story meaningless. The ending exists because of everything that came before, the characters' choices, the plot developments, the themes. The ending is meaningful precisely because it's the culmination of the whole story. Your life is the same. Your future exists, but it's meaningful because it's shaped by your choices, your relationships, your values. The fact that it exists in the block universe doesn't rob it of meaning. It gives it eternal meaning. Your life is a permanent part of the structure of spacetime. Everything you do matters forever. The philosopher Susan Wolf argues that meaning comes from loving something worthy of love and engaging with it actively. You find meaning by connecting with things that matter: people, projects, causes, experiences. And that's still possible in a block universe. In fact, it's eternal. The love you feel, the connections you make, the projects you pursue, they're all permanent parts of spacetime. Another objection: if everything already exists, why does it matter whether I make good choices or bad choices? My future self will exist regardless. But this gets it exactly backwards. Your future self exists in a particular way, happy or miserable, fulfilled or empty, healthy or sick, based on the choices you make now. You're not powerless to affect your future self. You are affecting your future self with every choice. The fact that your future self already exists doesn't mean your current choices don't matter. It means your current choices are what determine what that existing future self is like. It's like sculpting. You're sculpting your four-dimensional self with your choices. The sculpture already exists in the block of spacetime, but you're the one shaping it. Every decision is another chisel stroke, determining the final form. Here's my take on all these objections. I think the block universe is the best interpretation of our current physics. Relativity strongly suggests it, and no one has come up with a better alternative that's consistent with all our experimental evidence. But I also think there's a lot we don't understand about time, consciousness, and quantum mechanics. The final theory of quantum gravity might change the picture significantly. What I'm confident about is this: the naive view of time with an objective present moment that sweeps through the universe, transforming potential future into fixed past, is definitely wrong. That picture is incompatible with relativity. Whatever the truth about time is, it's more subtle and more strange than our everyday intuitions suggest. And I think that's beautiful. The universe is under no obligation to match our intuitions. The fact that reality is weird and counterintuitive is part of what makes it fascinating. We live in a universe that's far stranger than we ever imagined, and coming to terms with that strangeness is part of the adventure of being a conscious being. All right, we've spent 2 hours exploring the nature of time, the block universe, consciousness, and some deep philosophical questions. Now I want to bring this back to Earth and talk about practical implications. How does understanding this stuff change how you should live your life? First, let's talk about anxiety about the future. A lot of human suffering comes from worry. We're anxious about things that haven't happened yet. That might never happen. We worry about failure, rejection, loss, death. This anxiety can be paralyzing. But here's an insight from the block universe. Whatever you're worried about either will happen or won't happen. And in the block universe, it's already determined which. Your worrying doesn't change it. The future that exists in the block universe already includes either the thing you fear or the absence of that thing. Now, I'm not saying this should make you fatalistic or apathetic. Your actions still matter. Your actions are part of what determines which future exists. But worrying, the mental state of anxiously ruminating about possibilities, doesn't accomplish anything. It doesn't change what will happen. What does matter is preparation and action. If you're worried about an exam, studying changes your future. If you're worried about your health, exercising and eating well changes your future. But lying awake at night worrying without taking action, just making yourself miserable in the present without affecting the future. The Stoic philosophers understood this 2,000 years ago. Epictetus said, "There is only one way to happiness, and that is to cease worrying about things which are beyond the power of our will." Marcus Aurelius wrote, "You have power over your mind, not outside events. Realize this, and you will find strength." The block universe gives us a modern, scientific version of Stoic wisdom. The future exists. You can't change what will happen by worrying about it, but you can affect what happens by taking action now. And you can choose how you experience the present moment, regardless of what the future holds. Let's talk about regret. We discussed regret earlier, but I want to go deeper into the practical side. Regret is one of the most painful emotions, that feeling that if only you had made a different choice, your life would be better now. But in the block universe, the choice you made is the choice that exists. There's no alternate timeline where you made a different choice. The person who would have made a different choice would be a different person with a different world line. This doesn't mean your past choices don't matter. They determine what your present and future are like. But it does mean that wishing you had chosen differently is wishing to be a different person. And you can't be a different person. You can only be who you are. The question to ask is not, what if I had chosen differently? But given who I am and the choices I've made, what do I want to do now? The past is fixed. The future is undetermined from your perspective. You have the power to shape your future self, but not to change your past self. This can be liberating. You don't have to carry the weight of infinite regret about alternative paths not taken. There were no alternative paths. There's just the path you're on. and you can make that path meaningful and valuable going forward. The psychologist Kristen Neff has done extensive research on self-compassion. She's found that people who treat themselves with kindness and understanding, rather than harsh self-criticism, are more resilient, happier, and actually more motivated to improve. Self-compassion isn't about making excuses or avoiding responsibility. It's about recognizing that you're a human being doing your best with the resources and knowledge you have at each moment. The blocked universe perspective supports self-compassion. At every point in your world line, you made the choice that made sense given your brain state, your knowledge, your emotional state at that moment. You couldn't have done otherwise, because doing otherwise would have required being a different person with a different brain state. So treating your past self with harshness and contempt doesn't make sense. Have compassion for the person you were, and focus on becoming the person you want to be. Let's talk about mortality again, because this is where the blocked universe perspective can be most powerful. Death is terrifying for most people because we think of it as annihilation. We'll be here, and then we'll be gone forever. Everything we are will cease to exist. But in the blocked universe, you don't cease to exist when you die. Every moment of your life exists eternally in space-time. You at age 5, you right now, you on your deathbed, all equally real, all eternally present in the structure of the universe. When someone you love dies, they're not gone in an absolute sense. Every moment you shared with them still exists. Every conversation, every hug, every shared laugh, it's all still there in space-time. You just can't access those moments anymore from your current position in space-time. Think of it like this. Imagine all of space-time as a vast landscape. Your life is a path through that landscape. When someone you love dies, their path diverges from yours. You can no longer walk together, but their path doesn't disappear. It's still there in the landscape. The moments where your paths crossed still exist. The astrophysicist Michelle Thaler, whose husband died of cancer, has spoken about how the blocked universe gives her comfort. She said, "Every moment I had with him still exists. I can't experience those moments anymore, but they're real. They're as real as this moment. In a sense, we're still together in those moments, eternally. This doesn't take away the pain of loss. You still grieve because you can no longer create new moments with the person you loved. But it does mean that what you had together is eternal. Death doesn't erase it. And your own death? In the blocked universe, your death is just one moment in your world lying painful perhaps, frightening perhaps, but just one moment among tens of thousands of moments that make up your life. Your life as a whole, your complete four-dimensional self, is so much more than that final moment. The Stoic philosopher Seneca wrote, "You live as if you were destined to live forever. No thought of your frailty ever enters your head. Of how much time has already gone by you, take no heed. You squander time as if you drew from a full and abundant supply, though all the while that day which you bestow on some person or thing is perhaps your last." But the block universe suggests something different. Don't think of time as a resource that's running out. All the moments of your life already exist. You're not running out of time. You're experiencing your way through a finite but complete life. The question is not how much time you have left, but how you'll experience the time that exists. Let's talk about decision-making. If the future already exists, how should you make decisions? Shouldn't you just do whatever you feel like, since it's all predetermined anyway? No. Here's why. The future that exists is the future that includes you making thoughtful, deliberate decisions. If you abdicate decision-making and just do whatever you feel like, that will result in a different, and probably worse, future than if you think carefully about your values and goals. You're not powerless. You're not a passenger. You're the process by which your future is determined. Your deliberation, your reasoning, your weighing of options, these are causal factors that shape what happens. The fact that the outcome is already determined doesn't make these factors irrelevant. They're part of what determines the outcome. Think of it like this. Imagine a computer running a chess program. The program's moves are determined by its algorithm. But that doesn't mean the algorithm is irrelevant. The algorithm is what determines the moves. If you wanted different moves, you'd need a different algorithm. Your decision-making process is your algorithm. It determines what you do. The fact that the future already exists just means that your algorithm already has run from the God's eye view. But from your perspective, within time, you're running the algorithm. And running it while thinking carefully, considering consequences, aligning actions with values, leads to better outcomes than running it poorly. Here's a practical framework. When making decisions, ask yourself 3 questions. 1. What do I value? What matters to me? What kind of person do I want to be? 2. Which option best aligns with those values? 3. How can I implement that option effectively? This framework works whether or not the future already exists. It helps you make choices that reflect who you are and who you want to be. And that's what matters, not changing a future that would otherwise be different, but being the person whose future is what you want it to be. Let's talk about presence and mindfulness. There's a lot of talk in modern culture about being present and living in the moment. But what does that mean in light of the block universe? If the present moment isn't objectively special, if it's just your current location in space-time, does it still make sense to focus on being present? Yes, absolutely. Being present doesn't mean believing the present moment is objectively special. It means fully experiencing the moment you're in, rather than being lost in thoughts about other moments, past or future. When you're anxiously ruminating about the future or regretfully dwelling on the past, you're not actually experiencing the future or past. Those exist elsewhere in space-time, and you can't access them from your current position. You're just thinking about them, and in the process, you're missing the actual experience you're having right now. Being present means bringing your attention to your current experience, the sensations in your body, the thoughts in your mind, the environment around you. This is valuable not because now is objectively special, but because this is the only experience you're actually having. The other moments of your life exist in space-time, but this is the one you're experiencing right now. The meditation teacher Sam Harris puts it well. The past is a memory. The future is a thought arising in the present. All we ever have is this moment of experience. He's not saying other moments don't exist. He's saying that your experience is always occurring in what you perceive as now. So that's where your attention should be if you want to fully experience your life. Let me give you a practical exercise. Right now, as you're listening to this or reading this, take a moment to notice your direct experience. What physical sensations are you aware of? What sounds are you hearing? What's the quality of your attention? Just observe, without judgment. This is being present. It's not about believing the present is objectively real, and the past and future aren't. It's about experiencing the slice of your world line that you're currently at, rather than being lost in mental representations of other slices. Meditation practices like mindfulness are essentially training in attention control. You're learning to direct your attention to your current experience, rather than letting it be pulled constantly to thoughts about other times. And this skill is valuable regardless of the metaphysics of time. We're entering the home stretch now, and I want to talk about we still don't know. Because for all that physics has revealed about the nature of time, there are still massive mysteries remaining. The biggest mystery is the reconciliation of quantum mechanics and general relativity. These are our 2 most fundamental theories of physics. General relativity describes gravity and the large-scale structure of space-time. Quantum mechanics describes the behavior of particles and fields at the smallest scales. Both theories are spectacularly successful at making predictions, but they're fundamentally incompatible with each other. General relativity assumes that space-time is smooth and continuous. Quantum mechanics suggests that at small enough scales, everything becomes discrete and probabilistic. When you try to apply quantum mechanics to gravity and space-time, you get nonsensical results, infinities that can't be eliminated, breakdowns of the equations. For decades, physicists have been trying to develop a theory of quantum gravity, a theory that would explain how spacetime behaves at the quantum scale. And whatever this theory turns out to be, it will almost certainly change our understanding of time. There are several candidate theories. String theory is probably the most famous. In string theory, the fundamental entities aren't point particles, but tiny vibrating strings. These strings exist in a space-time with 10 or 11 dimensions, not just the 4 we experience. String theory might explain how space-time emerges from more fundamental entities. And if space-time is emergent, then time itself might be emergent, not fundamental to the theory at the deepest level. Another approach is loop quantum gravity, which treats space-time as made up of discrete loops at the smallest scale. In this theory, there's a minimum length, the Planck length, and possibly a minimum time, the Planck time. Below these scales, the concepts of space and time break down entirely. If loop quantum gravity is correct, then time is granular, not continuous. There are smallest units of time, quantum ticks of the universe's clock, and the arrow of time might be explained by how these quantum states evolve. A third approach is causal set theory, mentioned earlier, which Lee Smolin works on. This treats spacetime as a discrete set of events with causal relationships between them. Time has a fundamental directionality built into the causal structure. We don't yet know which, if any, of these approaches is correct. We might need new ideas entirely. But what's clear is that our current understanding of time is incomplete. The block universe picture emerges from classical general relativity, but at the quantum level, things might be very different. Another huge mystery: the nature of the Big Bang and cosmic time. The universe is 13.8 billion years old. We know this from observations of the cosmic microwave background radiation, the expansion rate of the universe, and other cosmological data. But what does it mean to say the universe has an age? In the block universe picture, all of time exists simultaneously. So from the God's eye view, the universe doesn't have an age. It's a four-dimensional structure that includes the Big Bang, the present, and the far future all at once. The age we measure is a property of spacetime. It's the duration along a particular path through spacetime from the Big Bang to now. But the Big Bang itself isn't an event in time, it's the boundary of spacetime. There's no before the Big Bang, because time itself began at the Big Bang. This is hard to wrap your head around. We naturally think, what caused the Big Bang? What happened before it? But if time began at the Big Bang, there is no before. Causation requires time cause comes before effect. Without time, there's no causation. Some cosmologists speculate about eternal inflation, or multiverses, where our Big Bang is just one event in a much larger structure. In these scenarios, there might be a kind of meta-time in which different universes are created, but we have no way of testing these ideas experimentally, so they remain speculation. The cosmologist Sean Carroll has proposed that the universe might be eternal in both directions, not just forward from the Big Bang, but backward too. In his model, the Big Bang is a lowest entropy state in the middle of an eternal timeline, and entropy increases in both directions away from it. This would solve the past hypothesis problem by making it symmetric. But this is speculative. The truth is, we don't really understand the beginning of time, or even if beginning of time is a meaningful concept. Another mystery: dark matter and dark energy. Observations of galaxies, galaxy clusters, and the expansion of the universe tell us that the ordinary matter were made of atoms, molecules. The stuff we can see and touch makes up only about 5% of the universe's total energy content. About 27% is dark matter, which we can't see, but which has gravitational effects. About 68% is dark energy, a mysterious force causing the expansion of the universe to accelerate. We don't know what dark matter or dark energy are. We don't know if they're particles, fields, or something else entirely. and they might have implications for the nature of time. Dark energy, in particular, is weird. It seems to be a property of space itself. As space expands, more dark energy appears. This is causing the expansion of the universe to accelerate, and in the far future, this acceleration will tear the universe apart. Eventually, billions of years from now, even atoms will be ripped apart by the expansion of space. This fate of the universe, sometimes called the Big Rip, would be a kind of end of time. Space-time itself would be torn to shreds. Or maybe the universe will just expand forever, getting colder and more dilute until nothing interesting can happen anymore. That's called heat death. Either way, the arrow of time has a destination. Entropy has a maximum, and when the universe reaches it, the arrow of time will disappear. There will be no more change, no more events, no more causes and effects. Of course, in the block universe, this endpoint already exists. The heat death or Big Rip is already there in the future portion of spacetime. We haven't experienced it yet, but it's as real as the Big Bang. Here's another mystery that will blow your mind: the fine-tuning of the universe. The fundamental constants of nature things, like the strength of gravity, the mass of the electron, the speed of light, have very specific values. And if these values were even slightly different, the universe would be radically different and probably couldn't support life. For example, if gravity were a tiny bit stronger, stars would burn out too quickly for life to evolve. If it were a tiny bit weaker, stars wouldn't form at all. If the strong nuclear force were slightly different, atomic nuclei wouldn't be stable. If the electromagnetic force were different, atoms couldn't form. The universe seems to be fine-tuned for life. Why? We don't know. Some physicists invoke the anthropic principle. We observe these values because if they were different, we wouldn't be here to observe them. We're selected for by the requirement that the universe support observers. Others invoke a multiverse. Maybe there are countless universes with different values of the constants, and we happen to live in one of the rare universes where the values permit life. This is speculative, but not crazy. Some versions of string theory and eternal inflation predict a multiverse. But here's the weird thing. Fine-tuning might extend to time itself. The initial conditions at the Big Bang were incredibly special, incredibly unlikely from an entropy perspective. Why? If the universe were just randomly created with arbitrary initial conditions, it would almost certainly start in a high entropy state, not a low entropy state. But we have a low entropy Big Bang. Some physicists think this requires an explanation. Maybe there's a mechanism that selects for low entropy initial conditions. Maybe there's a multiverse, and we're in a universe that happens to have low initial entropy. Or maybe time itself is fine-tuned, and only universes with certain temporal properties can support complex structures like life. We don't have answers to these questions. They're at the frontier of cosmology and physics. Another mystery: the nature of information. In recent decades, physicists have become increasingly convinced that information is fundamental to physics. The physicist John Wheeler coined the phrase "it from bit," the idea that physical reality emerges from information. In quantum mechanics, information behaves strangely. Quantum information can be in superposition, it can be entangled across space, and it seems to be conserved in all physical processes. This is the principle of unitarity. But what happens to information that falls into a black hole? Stephen Hawking showed that black holes evaporate over time, emitting radiation. But this radiation seems to be thermal random, carrying no information about what fell into the black hole. This appears to violate unitarity and create an information paradox. Recent work by Hawking, Leonard Susskind, Juan Maldacena, and others suggests that information might be preserved on the surface of the black hole, the event horizon, in a holographic way. The holographic principle says that all the information in a volume of space can be encoded on the boundary of that volume, like a hologram. If the holographic principle is correct, it has radical implications for the nature of space-time and time itself. It suggests that space-time might be emergent from more fundamental quantum information, and that the dimension of time might be less fundamental than we thought. These are deep waters, and we're just beginning to understand the connections between information, quantum mechanics, gravity, and time. Finally, the biggest mystery of all. Why is there something rather than nothing? Why does the universe exist? Why does time exist? Why do physical laws exist? These are philosophical questions as much as scientific ones. Science can tell us how the universe works, but it struggles with why questions at the most fundamental level. The philosopher Gottfried Wilhelm Leibniz asked, "Why is there something rather than nothing?" and called this the first question of metaphysics. And we still don't have a satisfying answer. Some physicists, like Lawrence Krauss, argue that nothing is actually unstable and will spontaneously produce something due to quantum fluctuations. Others, like Stephen Hawking, suggested that the universe might be self-creating through quantum gravity effects at the Big Bang. But these explanations just push the question back. Why do quantum fluctuations exist? Why do the laws that allow self-creation exist? You can't get something from nothing unless nothing already has properties and laws, in which case it's not really nothing. Maybe the universe just exists as a brute fact with no explanation. Or maybe existence itself is necessary. Maybe non-existence is actually impossible and something had to exist. Or maybe we're inside a simulation created by beings in a higher reality, in which case our universe exists because they created it. But then, why does their universe exist? These questions might be unanswerable, but they're worth asking because they remind us how much we don't know and how mysterious existence really is. We've spent 2¼ hours exploring the nature of time, and what I hope you've taken away is this. Reality is far stranger than it appears. Time is not what you thought it was. The future already exists. The present moment is not objectively real, and you are a four-dimensional structure in space-time, experiencing your way through existence one slice at a time. But we've also seen that despite all this strangeness, your life still has meaning. Your choices still matter, and your experience is still real. You're not diminished by understanding how time works. You're elevated. You're part of something vast and profound, a conscious pattern in the fabric of space-time, a way for the universe to experience itself. We're approaching the end of our journey, and I want to get personal. How do you actually live your life differently once you understand that the future already exists, but time doesn't flow? I've been thinking about these ideas for years, and they've genuinely changed how I experience my life. Let me share some practical insights that I've found valuable. First, the practice of temporal perspective taking. This is something I do regularly, especially during difficult moments. When something bad happens, I fail at something. I'm in pain. I'm going through a breakup. Whatever. I try to imagine looking back at this moment from the future. In the block universe, my future self already exists. That future self has already gotten through this difficult moment. From that future perspective, this moment is part of the past already over, already survived. That perspective helps me endure difficulty because I know, not just believe, but know given the block universe, that this moment will pass and I will survive it. But it works in the other direction too. When something good happens, I achieve a goal, I have a beautiful experience. I connect deeply with someone. I try to imagine looking back at this moment from the far future, maybe from my deathbed. What will I remember? What will have mattered? This helps me fully appreciate the good moments because I can see them as my future self will see them, as precious memories from a time that's now past. This practice is powerful because it's not just imagination in the block universe. These other temporal perspectives are real. My future self really does exist, looking back at this moment. My past self really exists, living through moments that I now remember. Temporal perspective taking is connecting with other slices of my four-dimensional self. Second, the practice of acceptance. This is related to the Stoic wisdom we talked about earlier. If the future already exists, if everything that will happen is already determined, then fighting against reality is pointless. The only rational approach is to accept what is and what will be, and to focus on what you can control: your actions, your attitudes, your responses. This doesn't mean being passive or resigned. It means distinguishing between what you can influence, your thoughts, your actions, your character, and what you can't: external events, other people's choices, the laws of physics. Accepting the block universe means accepting that you're part of a larger pattern, not the creator of that pattern. You contribute to the pattern through your choices, but you don't control the whole pattern. The Serenity Prayer expresses this perfectly. Grant me the serenity to accept the things I cannot change, courage to change the things I can, and wisdom to know the difference. In the block universe, what you can change is your own behavior and mental states. What you can't change is the overall structure of space-time. Wisdom is knowing that your choices matter. They determine your behavior, while also recognizing that you're part of something much larger than yourself. Third, the practice of gratitude. In the block universe, every good thing in your life exists eternally. That conversation with a friend, that beautiful sunset, that moment of insight, they're permanent features of space-time. They're not going to disappear or be erased. They exist now and forever. This makes gratitude not just appropriate, but almost obligatory. You should be grateful for the good things in your life because they're eternal contributions to the structure of space-time. They're permanent additions to the universe. I keep a gratitude journal where I write down 3 things I'm grateful for each day. This practice is backed by psychological research. Gratitude consistently makes people happier, more resilient, and more satisfied with life. But for me, it's not just a psychological technique. It's a recognition of the eternal reality of good things. When I write, "I'm grateful for the conversation I had with my friend today," I'm not just saying, "That made me feel good." I'm saying, "That conversation is now a permanent part of the universe, and I'm glad it exists." Fourth, the practice of presence. I mentioned mindfulness earlier, but let me go deeper. Presence is about fully inhabiting the slice of your world line that you're currently at. It's about experiencing this moment completely, rather than being lost in thoughts about other moments. I meditate for 20 minutes every morning. Meditation isn't about achieving some special state or becoming enlightened. It's just about training attention. You practice noticing when your mind has wandered to thoughts about the past or future, and you gently bring it back to present experience: breath, body, sounds, sensations. This practice doesn't contradict the block universe. In fact, it's perfectly consistent with it. Yes, all moments exist. Yes, past and future are just as real as present. But the moment you're experiencing right now is the only one you can actually experience. The others exist elsewhere in space-time, and you'll experience them when you get there. But right now, this is all you have. Presence is about doing justice to your experience. It's about not wasting this moment by being mentally absent, fantasizing about other moments. It's about being fully here, fully alive, fully experiencing this slice of your 4-dimensional self. Fifth, the practice of compassion. Understanding that everyone else is also a 4-dimensional structure in space-time, trying to navigate their experience just like you are, naturally generates compassion